Hello and welcome to the third in our series of videos on the ARM Cortex M4. My name's Sam Walsh from the School of Electronics at the University of Manchester, and in this video I'm going to continue on with the project that we built last time, and I'm going to teach you how to make a GPIO and output. Now there are C libraries for this, abstraction libraries, that make it really easy, where you can just basically say GPIO dot is input dot output. But I think in this video I want to show you how to do it manually, like at the processor level in C. So it's going to be a little bit more complicated, and from this point on we'll probably just use the abstraction libraries, but I thought it'd be useful for you to see it once. So there is a user LED on this board, and that's the one we lit with the Blinky project. If you go to connectors in the schematics, you'll see LD2. It's there, and LD2 attaches to the processor pin GPIO A5. So we're going to be lighting A5, hopefully, if everything works. So let's go back to our project. And how do we begin to configure the GPIO? That's probably your first question. Right, well, we're going to need to open the reference manual. So if we just go to here, and we want to go to the page on GPIOs, which is here on page 145. Now, the big difference between, if you've come from a PIC microcontroller background, like you might be used to things like tris registers, port registers, and lat registers. So you configure the tris, you read from the port, and you write to the lat. Now, the STM series do have like a lat and a port, except it's called an ODR and an IDR, an output data register and an input data register, and whatever you put there will be sent out of the microcontroller, and whatever you read there will be read in. But instead of having one tris register for configuring whether the port's an input or an output, there's actually 4 on these ARMs. You've got a mode register, a type register, a speed register, and a pull-up, pull-down register. So first of all, the mode register works like the old tris register did. It just, well, if you've not come from microchip, I'll drop the tris talk now. But the mode register just it configures whether it's going to be an input or an output. The type configures whether it's going to be a pull-up or a pull-down, a push-pull or an open-drain type of output. The speed, because you can clock the GPIOs at all different speeds. They can be low speed, medium speed, or high speed. High speed being the clock frequency, which is 84 megahertz. Then you've also got a pull-up, pull-down register, because every port pin on the microcontroller has pull-up and pull-down resistors. So you have to configure whether you want them or not. So the first step is we need to set a clock for this GPIO. Now, everything inside, every single peripheral on the microcontroller needs to have a clock sent to it. So if you're planning on using a timer or a PWM, you need to make sure it has a clock sent to it. And I'm going to open no, I'm just going to go back. What we need to do is go to the RCC register, which from memory I think it's about page 117. Yeah, so we need to go to the RCC register, which is the reset and clock control register, and we need to make sure there's a clock being sent to GPIO A. And the way we do this is there's something called the RCC GPIO enable register. When I find it, I'll look on the side. Here we go. The RCC AHB1 peripheral clock enable register. So this sends a clock to either DMA or the CRC module, but most importantly for us, it sends it to the GPIO A. So it's a 32-bit long wide register, and we need to set bit 0 to be 1, okay, to enable the clock. So we'll do that now. If we just pull up our Kyle project. So you need to make sure that you have the device. Oh no, we don't have the device code there. Okay, so the first step is we need to include the header files for our processor. I probably should have done this in the last video, but oh well. So here you need to type stm32f4xx.h, and if we do build, you should say no error, and when you click this plus here now, you should see a lot of header files appear for the board that we're going to be using, the STM32F401. Okay, so then we need to access that register can control bit. So what we need to do is RCC, and the way you do it in these is it's a dash then an arrow to access the struct members. And if you remember, it was the AHB1 peripheral clock enable register that we need to set bit 0 to 1. Okay, so let's get that one. RCC mix.ahb1 enr equals 1. That's going to turn off all clocks. In fact, I think we should do an OR equals to leave everything else the way it is. Okay. I'll just add a bit of comment there. In fact, I'll do enables cat type. Okay. Right, so the next step we need to do is we need to go to the GPIO mode register. So let's pull those up. Right, so we're here on page 157 of the reference manual, the GPIO port mode register, and there's a mode register for GPIO A, B, C, D, E, F, etc. So what you need to do is set the GPIO pin that you're going to be using. So for GPIO A, we've got A0, A1, A2, A3, A4, A5, A6, A7, A8, 9, 10, up to 15. Each GPIO port is 16 bits long. So if we want to set GPIO 5 to be an output, we need to say an output is a 0, 1 in those two columns there. Right, so this is going to get a little bit complicated, I think, while I explain how we do all the bit shifts. But essentially what we want to do is we want to first of all blank these two values because we're not sure what they were originally, and then we're going to OR with those two blanks the value that we're going to send in. So let's pull up our thingy, our project, and we go GPIO A arrow mode register, and what we want to do is we want to send 3, because 3 is 1 1 in binary, isn't it? So we want to send 3 shifted across 10 places. So because if we go back here, 3 will be 1 1 there, and if we shift it 1 2 3 4 5 6 7 8 9 10, that'll be 1 1 in those two there once we've done the shift. Right, so let's do GPIO A and equals, because and will blank equals. So we want to do 3, and 3 UL just stands for 3 unsigned long. It's a 32-bit number shifted across 10 places. But also we want to do a tilde here, because that's going to not this value, because what we did there was we shifted 3 across 10 places, and everything else was going to be 0, but this will make 0 0 shifted across 10 places, but everything else be 1, which is what we want to do. We only want to blank 2 numbers off. I know it looks confusing, but you will get the hang of it. And then, so we've not actually set anything there. We've just blanked the 2 configuration bits. So let's actually write something to those now. And what do we want to do? We want to write a 0 1 to be an output. So no, wrong program. So we want to do an OR equals. Then we just want to do 1 shifted across 10 places. Okay, so that's configured the output. Then, by the way, real convention is we do this, we do 2 times 5. So you can see that we're sending 2 bits 5 across, so it's easy to kind of see which GPIO we're working on if we do it this way. We can always see that that's for configuring GPIO 5. Okay, so let's put some code there. We'll say configuring for output on GPIO A5. Okay, so next step is we need to tell it whether it's going to be a push-pull or an open drain. So if we go to the type register, output type register, 0 is going to be a push-pull, and that's when it's reset state anyway. So we don't actually have to set anything there. I will set it just to show you. So we want to do just set it to 0. I think, yeah, yep, 0, shifted across 4. In fact, there's no point setting it because it's a 0 anyway, so we're just going to leave that one. If you did want to set it to be a 1, I'll leave this line in. So that one's shifted a 1 across 2 times 5 places, so that's put a 1, making it an open drain. But we don't want to do that. We want it to be a push-pull type. So I'll leave that line out. Then the next thing is we need to set the speed. So there'll be an O speed R. And we need, what kind of speeds do we have? Let's go to the speed register here. And it can be low speed, medium speed, fast speed, or high speed. Now if you go into the data sheet, I'll just pull it up, give you a quick look. Okay, so if we download the data sheet and have a look, you will find somewhere in here it has all the different speeds that you can run the GPIOs at. I'll just find, yeah, here it is on page 94, the input and output AC characteristics. And it has all the different speeds and what you set them to. So you can go all the way to 84 megahertz and down to, I think, is it maybe 10? But anyway, we won't worry about this for this video. We're just going to set them to be medium speed. So if we look on here, medium speed is a 0, 1. So we need to shift across. Well, we need to, first of all, like we did with the mode register, we need to blank off these 2 bits here by ANDing them with not 3. Then afterwards we need to set 0, 1 in those 2 though. So we need to do AND equals not 3 UL shifted across 10 times, but 2 times 5 is easier to read. So that's blanked off those 2 bits. Now to actually write the value to those 2 bits, we need to do speed register. Oops. We need to OR the value. So OR equals, we send 0, 1, so it's just 1 UL, and we're sending that across 2 times 5. So let's actually set the bits. So okay, and the last register we have to set is the pull up and pull down register to decide whether we want pull up resistors or pull down resistors. So if we go down again, we should find the pull up pull down resistor somewhere. Here, the GPIO pull up pull down register. So if we leave it as 0, 0, there's no pull up and no pull down resistors. I'll leave this line in here as an example for you. If you did want to set the GPIO, the pull up and pull down resistors. So I've set them to 3 there, which should be nothing, which should be reserved. So I'll set them to 1, 0 to be pull down resistors. So 1 0 would just be 2. Okay. Right. I'll leave these lines at the end just for your knowledge. Okay, so you'll be glad to know that that is everything you need to do to configure the GPIO. I know it's really long-winded, but at least now you understand it. Okay, so the final stage is we just need to output something on the GPIO. So the output data register, we need to set the, let's go and get the output data register. So this is the output data register, and you'll notice there's only 1 bit for each of the outputs because you can only output a 0 or a 1. Whereas the configuration registers usually have 2 bits for each of the configurations. So if we want to light the LED on GPIO A5, we need to put a 1 on this ODR5. So that's a 1, 2, 4, 8, 16, 32. We need to make the output register equal 32 to just turn this 1 bit on. So let's do that. So we got, oops, get rid of that breakpoint. So GPIO A arrow ODR equals 32, and then alright, turn on LED and GPIO A dash ODR equals 0. So that'll turn the LED on and then it'll turn it off again. Okay, so I've got my LED, which I mean is my board, which you should hopefully be able to see in the corner. And for this, we're going to do some debugging. So I'll set a breakpoint there. And in the last video, I just showed you how to load the video to Flash, which is pressing load. But if you press this D up here, that'll take us into debugging mode. Okay. You may have to build this. I just built it then, but you may have to build it before going into debug mode. Okay, so what we're going to do is step into the code. So step. This is all just configuring the ports to be outputs. And if you look, the LED is currently off. But if I set this output data register now to 32, it should turn the LED on. So, and hopefully you can see that. It's very, very small, but there is an LED on just there. And then on the next line now, when I set the ODR to be 0, the LED should go off. And it does. So that's all there is to it, really. You've just got to make sure you set the mode to be an input and output, or the speed. In fact, if you don't really worry about speed, if you're not worried about speed, then the only thing you have to set is this mode register and make sure there's a clock going to the GPIO. So even though it looks more complicated, there's not actually that many more steps than if you were doing this on a simple microcontroller like a PIC. Right, in the next video, I'm going to show you how we do this using the abstraction libraries, because you don't want to be doing this every single time you light an LED. Okay, thanks. See you next time.